Hey there, welcome to Kobe Canal, your hub for tech, tutorials, and powerful problem solving. Whether you are into programming, networking, or data tools that make your life easier, you are in the right place. If you are new here, consider subscribing so you don't miss out on any of our upcoming videos. Now let's jump right into today's video.
In this video, I'm going to discuss with you what a computer is, the language of computers, and then an introduction to computer programming. Practically in this video, we are not going to be particular about any programming language. I just walk you through some fundamentals of programming, the things you need to know before you start out to program. And before we dive deeper into the fundamentals of programming, we have to understand the device that we are going to program. That device is a computer. A computer is any programmable electronic device that accepts inputs, right, in the form of data and processes this input to give a meaningful output. The computer processes this data by obeying a given set of instructions. And to give the computer an instruction, you need to understand the language of computers, right? And what then is the language of computers? What language at all does the computer understand? The computer understands a language we call the machine language. The machine language is simply a binary code, that is zeros and ones. It is these zeros and ones that the computer represents any data that is given to it. So, for instance, if I input my name into the computer system, the computer represents my name in zeros and ones. In other words, it represents my name in the form of binary. Now, since we know the language that the computer understands, we have to dive deeper into a basic introduction to computer programming. In the late 90s, the programmers then were writing code in binaries, and this was very, very difficult for them. Thank God, through the work of some computer scientists, they have been able to come up with high-level languages like Java, C++, JavaScript, and so on and so forth. Now let's get into an introduction to computer programming. Computer programming is simply learning how to give the computer an instruction. Giving the computer an instruction is what we call computer programming. To be able to understand, to be able to give an instruction to the computer, there are a few things that you need to understand. First of them, we have to understand what an algorithm is, data types, operators, variables, control structures, and loops. I'm going to explain each of these things to you in the next slides. And what then is an algorithm? An algorithm is a step-by-step procedure to solve a problem or perform a task. Think of it this way. Imagine you wake up early in the morning, you check your time, and you realize that you are late for work. The next thing is that you plan that how do you get to work early? That is the problem at the moment. So the processes that you go through in moving from your home to the workplace early is what we call an algorithm. The process or the steps that you use to move from your home to the workplace without being late is what we term as an algorithm. An algorithm should be finite, clear, and then effective. How do you write an algorithm? There are various ways of writing an algorithm, but the most popular way is writing an algorithm in the form of a pseudocode. Pseudocode, as the name suggests here, is not a natural code. It's a false code. It's a false code. A pseudocode is simply a way to describe an algorithm using a plain English language syntax. Your pseudocode can be in any language of your choice. If you speak Spanish, you can write your pseudocode in Spanish. If you speak French, you can write your pseudocode in French. If you speak Tree, you can write your pseudocode in Tree. Take this as an example. For instance, write an algorithm to add two numbers. In this example, you are not expected to use any programming language to write the algorithm. You can simply express your algorithm or your way of thinking in plain English that humans can understand. Let's move to the world of data types. Data types simply refers to the different forms of data that are input into the computer system. The data can come in the form of an integer, a float, a character, a string, and then a boolean. There are a lot of them. Integers are simply positive or negative whole numbers, including 0. And in what case are integers relevant? For instance, think of it as you visiting a website and then you are requested to enter your age. It is more likely that you enter your age as a whole positive number. I'm not sure anybody will enter 23.5 as his or her age, or 23.2 as their age. So in this situation, you are making use of integers. Now float 3.14, yeah, good. If you are somebody who is into cryptocurrencies, who is into finance, we write the money that we deal with in decimals, right? In decimals. And these are floats. And the decimals can either be positive or negative, depending on the case of use. And the next part are characters. Characters are very fundamental. A character, the letter A, the letter B, the letter C, they are all characters. There are several characters now, and there are a lot of characters now. And then the next thing is a string. Strings are just simply characters that are joined together. So strings are actually characters. And then the last one being a boolean. A boolean is just two states, a true or a false. Take for instance, I can ask you, Kwame, have you eaten this morning? You would answer by saying a yes or a no. In this situation, you are making use of the boolean data type. Operators. The data types that have been mentioned above have several operations that can be performed on them. And the signs or the symbols or the kind of operations that can be performed on them are aided by what we call operators. Operators are simply symbols that perform operations on values or variables. We have several types of operators. We have the arithmetic operator, relational, and then logic. The arithmetic operator is what enables us to perform mathematical computations, and these operators are addition, subtraction, multiplication, and then division. I believe everybody in their basic school learns how to perform simple calculations with addition, subtraction, multiplication, and division. So we should be cool with this. And then we have the relational. These operators are used to check for equality, right? So we have the equal to, this is equal to, for equal to, this is not equal to, greater than, and then less than. There are several of them. If you start to pick any programming language, you come across several of these relational operators. We have logical operators. Logical operators and or not. I'm going to give some examples, the real world examples, where we will make use of these logical operators. Now imagine you're a teacher and you will require two students to perform a particular task for you. But at the moment, you have only one student. You tell that one student to go to a certain class, and if the student enters the class and there is no teacher in the class and all the students are idle, you should call one of them for you. In this case, you are instructing the student that the student should enter a particular class, check if there is no teacher there, and the students are not doing anything. So in that case, if these two conditions are met, the student can call another student to join him to perform the task for you. In this sense, the student is making use of the logical end. Yeah, great. And let me use the same scenario. This scenario, you need a pen or a pencil to write an essay. So you tell the student to go into the class and look into your bag for you. If he finds a pen or a pencil, you should bring them, right? You should bring just one of them. So in this situation, the student is making use of the or operator because he is to check if there is a pencil or a pen. If he get any of them, you bring them. If he doesn't get any of them, he returns with an empty hand. That is it. And the not operator is very simple. It's just a negation. So for instance, you fall into an argument with a friend. The friend says that he's more handsome and you be like, no, you are ugly. That is an example of the not operator. It's a negation. Wait. Variables. When a computer is performing an arithmetic operation or is storing a value, it stores this using what we call variables, right? So variables are stored in a place called the memory address of the computer system. So for instance, if you are writing a program that takes the details of a user, all the details of the user, such as in first name, last name, age, current school, parent, they will all be stored in what we call a variable, and these variables are stored in the computer system. Great. What then are control structures? As you are giving an instruction to the computer using a programming language, you come across what we call control structures. Control structures are what define the flow of a program. They are simply the conditional statements like if, else if, or else. Let me give a very simple example, a very simple use case of the if statement. Imagine you are given 50 cedis by a friend, and your friend instructs you that if you are angry, just take 20 Ghana cedis out of that 50 Ghana cedis to buy food. That is a very simple instruction given to you by your friend. In this case, if you get angry, you will likely take 20 Ghana cedis from the 50 Ghana cedis. If you do otherwise, your friend might charge you for taking an extra amount. So in this case, your friend is giving you a flow or a direction, and that is one use of the control structures. You will use them a lot, so it's very good you understand them here. And then the else is more or less like a fallback, right? If a certain condition does not hold, your fallback is the else. For instance, if you don't pass an exams, then it means you have failed. Very simple. If you pass an exams, it means you didn't fail. So the else is acting like a fallback. Great. And then iterations. What then is an iteration? Take this for instance. From Monday to Friday, if you are working on a 9 a.m. to 5 p.m. job, you are going to wake up early in the morning from Monday to Friday to go to work. This event happens 5 times in a week. In other words, you are repeating a particular event. So in computer programming, we use iterations or loops to repeat a block of code multiple times. The common loop types or that we use are the for loop and then the while loop. In this video, I'm not going to dive deeper into how we use the for loop or the while loop. We'll visit this once again when we start actual programming, right? So yes. Now the question is, after understanding all these things, what programming language should you start with? In my view, there is no right or wrong programming language to start with. It depends on the area or which parts of the IT that you want to specify or you want to venture into. Maybe probably you would like to dive deeper into web programming. You would like to be in embedded systems. You would like to be in crypto. So depending on these areas mentioned, there are languages for it, there are frameworks for it. But for me, just pick just a very single language. Try to understand the fundamentals of programming very well with that language, right? And then you will be fine.
If you enjoyed this content, don't forget to like, comment, and subscribe. Turn on the notification bell so you never miss an update. Follow for more tutorials, tech insights, and programming tips.